Welcome to WebAssembly with Rust. This is a talk I gave recently at the Kentucky JavaScript User Group. Unfortunately, I lost the audio to that talk, so I thought I'd go through it once again here quickly for folks on the interwebs and for anybody who might want to check back in and maybe couldn't make it to the talk. So first off, just a disclaimer here. I'm not a Rust expert. I'm actually learning it myself as I go along. My day job, I'm mostly working in Java, JavaScript, TypeScript, higher level languages like that. But I recently started delving into Rust in order to try to pick up a systems language, and also because of the compelling story Rust has for working with WebAssembly. So I'm just going to share some of the things I've learned in my little dive lately, and hopefully maybe they might pique some people's interest out there and help you all get started. So really quickly, what I'm going to cover here is what is WebAssembly, what is Rust, why would I use them together, a little bit of basic Rust syntax and standard features. We'll try to go through that quickly and just give you a taste, and then we'll dive in with a little bit of Rust and WebAssembly combined, kind of try to tie them together. And then I'm going to show some quick demos of some of the projects I've been working on, some of the things that sort of actually got me interested in using WebAssembly and why I thought it might be a good idea. So in a nutshell, WebAssembly, often called WASM, is a binary instruction set for the web. It's an instruction set, and it's also a simple stack-based VM that lives in the browser. That's the runtime to execute these instructions. And yeah, some of you may be having some flashbacks to the 90s. This does sound a lot like Java Applets. I'd say it differs in the way it's being developed and presented to the world. It's being developed as a standard and then implemented by browser vendors. It's not being delivered by a single company as a third-party package to install. But in a lot of ways, the tech is similar to Java. One of the cool things about it is that it's already available in most browsers, so you can start using it today. And I'd say it's production ready, though as you'll see, there are still some rough edges to it and working with it. So why would you want to use WebAssembly? What's it good for? We've already got ES6 or whatever we're on these days. It's already pretty good. JavaScript runtimes are really fast, but I think you've all noticed the trend on the web is towards rich client-side applications, or at least it's a thing you can deliver on the web these days, and more applications are choosing to go that route. I personally think it's great to be able to run very rich applications that can just live in my browser, can execute on any operating system, and can go away when I close that browser session. So basically what WebAssembly is going to let you do is just take that a little farther. Yes, JavaScript's great, but if we had, and we now have, a binary format for delivering these applications, the same applications can be delivered in a smaller package. And they can execute in this this runtime for WebAssembly at near native speeds, very close to native speeds. So for certain things, like very powerful web apps, things like think document editors like Google Docs and the corresponding spreadsheet application that delivers, think in-browser video games, think some of the new graphic design applications that we've started to see in the browser. All these are the sorts of applications that can really benefit from WebAssembly. So how do you write WebAssembly? Well, you don't normally. WebAssembly is really a compilation target. You're typically going to be developing in some other language of your choice and then compiling to WASM. And there are quite a few languages out there that are already offering support to compile to WASM. C++ was one of the first on the scene, but also there's projects out there I've heard of to compile C# as well as Java. Yep, you can compile Java and run it in the browser. That is what I said. Again, everything old is new again. But the C# stuff actually sounds really interesting. I've heard that they've got Mono actually compiling to WebAssembly to provide the runtime, and they're able to actually stand up the Razor rendering engine and execute that inside WebAssembly. I haven't worked with this myself. I've heard some podcasts on it. One of the audience members at the talk when I presented this actually mentioned that he had in fact played with this and had been able to have some success with it for standing up some simple applications written in C#. So pretty cool. A lot of good stuff out there. Personally, though, playing around with it, I find that the Rust toolchain around this is developing really quickly and seems to be relatively mature. Um, and I found the ergonomics there to just be really great compared to what I've seen when I tried to compile C++, for example. Plus, Rust is just a very interesting language, as you'll see. So I think it's pretty good for this task. So just first, a little more fun though here. So yes, you shouldn't write WebAssembly raw, but you can. So let's take a little quick look at some naked WebAssembly. This string of hex values down here is in fact just some hex that I copied out of a hex editor of a wasm file here. And I'm going to show you in a second the watt equivalent of this. So wasm comes in two formats. There is the binary format, which is executed by the VM, but then there is a slightly, emphasis on the slightly more readable assembly format that you can specify in watt files. And so that's going to, down the road potentially give you some insight into debugging, make this a little less opaque if you do need to really get down and dirty and look at this WebAssembly code. So really quick here, what we're going to do is I'm going to show how you can create very basic watt file and assemble it into a wasm file. So there's actually a little node application I'm going to use here to do this, and it just has one or two basic dependencies. I actually copied this basically out of a tutorial I saw online. There's a really cool blog post on this, so I will have that linked down below this video. And there's the link there as well. So this node application is just going to read in the watt file that we're going to create here in a second, and it's going to call that dependency to do some assembly on it and then output it into a wasm file. So right now we're just going to go ahead and create the watt. And you'll see here lots of parentheses. It kind of reminds me of Scheme, definitely having flashbacks to the Lisp-like languages. This is going to be just a really simple function here that we're going to define that returns a 32-bit integer. And we're going to go ahead and in the just return 42, meaning of life. You can't get any better than that. So you export here, and you export what name you want to use for the function. So when we pull this into our JavaScript here in a bit, you're going to see we're going to call it using hello world, and it is going to just return us 42. So what we're doing now there, you see below there, we're running the assemble.js that produced the wasm file. So you can see there that wasm file is now present. So now we're going to look at index.js here, which I've already written up, but basically it's going to read in the wasm file, do just a little bit of more transformation on it, and then out of it we get instance.exports.hello world, our function there. So we're just going to log out the results of calling hello world. And away we go, 42. Doesn't get any better than that. So that's just a really quick demonstration of that, but basically don't do that. But it is good to see. So with that out of the way, what we're going to do here now is come back over to the Rust side of things. And we're going to quickly kind of talk about what Rust is and show some quick examples of how you can use it. So Rust is a modern language that preserves the speed and memory efficiency of languages like C and C++. It was originally created at Mozilla in 2006. It achieved its stable release in 2015. I was kind of surprised to learn this. It's actually older than I thought it was. It's still, though, considered to be a relatively young language, but it is starting to stabilize from what I've seen and is definitely production ready. Um, it has a strong emphasis on safety, as you'll see. So it has a lot of interesting compiler checks, which are both the blessing and the curse of Rust, but it's really part of what drew me to it. Though the biggest thing that drew me to it here is this last bit. It is not a garbage collected language, but you do not have to manually allocate and free memory. I mean, what? So that's pretty surprising, and we'll get into in a little bit how that actually works, but they've essentially baked mechanisms for indicating to the compiler when things should and should be allocated and should be freed without you having to actually manually call some sort of drop function, or without having to have a garbage collection system running in the background. So it's a very novel approach to this problem, something which I hadn't really seen before, and it is part of how they achieve that efficiency that's referenced there in the first bullet point. Other thing that I really love about Rust is it has a great package management system called Cargo. I think package management is nearly as important as the language itself when choosing an ecosystem, and a lot of package management systems out there seem to be repeating mistakes of previous package management systems and simply going through the same growing pains that a lot of those ecosystems have already gone through. Whereas Cargo seems to have really kind of taken a look at and learned from the past and learned from its predecessors. For example, right from their document page, quote here, take care when publishing a crate, because a publish is permanent. The version can never be overwritten, and the code cannot be deleted. That, my friends, is music to my ears. You know, some of you may remember a while back when NPM had its little debacle that broke everybody's builds because someone decided to take their toys and go home. Um, so that's a problem when we're all relying on the shared public infrastructure. So NPM has since dealt with that, but you really need to kind of deal with that up front. That needs to be an explicit part of the contract. I mean, there was nothing wrong with that guy taking his toys and going home, really, because that wasn't part of the contract that he signed up for when he submitted it to NPM. But I would argue that it probably should be. You really need that mutability if you're going to depend on a package management system in real-world production scenarios. So it's nice to see Cargo kind of getting that right up front. I also give a quick shout out to this Cargo Pants open source plugin that's out there. This is basically a application out there that can help you to audit your dependencies and get some insights into potential vulnerabilities in there. Some folks I know are working on this, and it's really cool little tool, so definitely go check that out if you're playing around with Rust. So Rust, I think, is a really great tool to add to your belt. And one thing I've noticed, I could see doing large applications in this, but I could also see it being great as just sort of something to pull out as part of a broader application. In fact, I think that's kind of, from reading around, that seems to be a lot of where it's gaining traction as, say, for example, it's described as being used by components of Azure. I've also understand that parts of NPM's backend infrastructure have been rewritten in Rust. And then, of course, Firefox is leveraging Rust. That was sort of, as I understand it, the original itch that was being scratched when the team started working on Rust. But I think if you're working on a project and you're sort of hitting some bottlenecks, you don't necessarily have to rewrite everything in Rust. You can rewrite some of the compute heavy pieces of your workflow in Rust and then hand that off. So it can become part of your existing applications, part of your Python application, part of your Ruby application, whatever higher level language you're using. And that again is actually kind of what we're going to be doing here, and what drew me to it with the WebAssembly story, because with WebAssembly you can continue to leverage, JavaScript and all that goodness, but for certain tasks you can hand off to the WebAssembly layer. So really quickly, we'll kind of cover the Rust Hello World just so you can see what that looks like. We won't go too much detail. I won't cover setting up the tools. There's plenty of great tutorials for that. And in fact, you'll see if you have cargo installed and you run cargo new hello world bin, it basically creates hello world for you. It's all the code is there, so you can just do that and see it and look at it on your own. Same thing, I like to use CLion for editing Rust, which is an IntelliJ tool. If you create a new Rust project in CLion, hello world's basically there. But real quick, we will just kind of starting from, we have a cargo toml file here. This is how cargo specifies dependencies and such. This application has none. You'll see here cargo lock if you're familiar with npm or other package management systems. That'll probably look familiar. And then we'll go to our main.rs. So our Rust files are going to be .rs extensions, and basically you see function there is just fn. So we're just giving it a main function, and we're going to print bang, and we're going to print some text. You can also do print line. That's probably more appropriate for a hello world, but I decided to type print bang for reasons unknown. But you'll notice there too that bang syntax indicates this is a macro, not really important right now to understand for this, but as you learn more about Rust, you'll start to see those and you'll start to get a better understanding of those. And you'll see there you can also do cargo run, and you'll also get out, this is just another basic hello world. So you can either run it right there in CLion, or you could run it on the turbo with cargo run. So with that out of the way, let's get just a little more complicated. We're going to just quickly run through basic structs and enums, and then we're going to get into my favorite topic, ownership. So structs are a little interesting in Rust. As you'll see, they're probably familiar with structs from other languages, though I would compare structs in Rust to being more like what other languages call classes. It's not really exactly like either, but you'll see here that the interesting thing about a struct, you can create a basic struct and it'll kind of look similar to what you're familiar with, like C structs, but you can implement methods on that struct. And struct is really the way that you're going to create objects with state and methods in Rust if you want to do that. So we're just going to give it a string called name here and an age. We'll make that unsigned 32 because I don't think you can have a negative age, though. I don't know. I guess you can. And we'll make an instance of that called field agent. And we'll just have to give it a name. It's going to give us red squigglies and be unhappy until we've supplied all these fields. So we'll go ahead and name this field agent Maxwell Smart. And we'll give Maxwell Smart an age. Really timeless, I think, and very much alive. Still kind of unhappy with me up there, and that is because what I'm passing there is a string literal or a slice, and that's a bigger topic, but what it really wants there is an actual string, which is going to be stored on the heap versus compiled into my application and stored on the stack. So I've told it it's a string, so it needs to be a string. So that string from there is just going to take care of that for us and turn that into an actual string allocated to the heap. So here we go. The agent's name is fieldagent.name. So nothing too surprising there. If you've written code in any C-like language, you've seen something just like this before. So beneath all the warnings there, you'll see the agent name is Maxwell Smart. It's warning me that I haven't used age. So basically, Rust compiler is kind of like a compiler plus linter. It has opinions about things, and it will tell you those opinions. Personally, I like that. I am a fan of I want to know the style basically. What are the recommended style guides for the ecosystem I'm working in, so that I don't write libraries that are gonna muck up other people's code, or pull in libraries written by other people that muck up my code. I think it's kind of nice when we can play by the same rules. So I like that it does this. It can be a little chatty sometimes. There's probably some ways to adjust it. Just beware. You're going to notice that as you work with Rust, in addition to the compilation errors, it's going to yell at you about a lot of other things. And that there, as you saw, was what I was talking about earlier, where basically we've just implemented a function on this agent here, on this agent struct. So now we have this function available to us, and by passing in that and self, that reference to self, that makes this an instance method. I'm going to call an instance method. That may not be the correct technical term in Rust parlance, but to me, thinking of it as instance methods and static methods is the best thing I can come up with. They basically behave that way. So you'll see here that that works. Hello 99. We could have, if we wanted, reference something like self.age there. Now you'll see if I add another function here and I leave out that and self argument, it's going to actually compile this as though it were a static method, and I'll instead call it on agent rather than any particular instance of an agent. And that and self, you notice in that first method, I didn't have to actually apply a self to it. In fact, if I'd had other arguments after it, I would just start by supplying those. It's just sort of a magical word there. It basically is going to, the compiler is going to bake in a reference to self for us to that, and then stick this on the instance. So whatever you're calling it on will become that self. But there you go. So we said something else. I'm like a static, hello 99. So that is the very simple basics of structs there. So next thing we're going to cover is enums. And enums are pretty darn cool in Rust. These are not your granddad's enums. They have managed to teach an old dog new tricks. And I was told in the talk, some Haskell and Clojure lovers told me that this is not necessarily a new thing. This was new to me. I think it's pretty cool. So we'll just go through some very quick examples using enums here. We'll start with a simple old school enum here that won't look, will look pretty much like what you're used to an enum looking like. So we'll call our enum field position, and we'll give it, you know, a possible empty state you can find here and an occupied. So this is just sort of a setup, like maybe if I was making a game and I wanted to have some sort of playing field, and you might have squares that were, say, empty or squares that were occupied, you might want an enum like that. And then before we get to some of the other enum features real quick, what we'll see here is matching, which is another cool thing about enums in Rust. So in Rust, after we define the actual enum instance here, you'll see we're going to match on it. You have this match operator, and one of the things you'll notice about it is that it is exhaustive. So we're going to match on field position 1 here, and you're going to see some red squiggles, and you would see the compiler unhappy if you try to compile it until we've defined something to do for each of these possible states in the enum. So right now, we're going to tell it what to do if it's empty, and then you'll see we'll have to tell it what to do if it's occupied. And this here on the right-hand side is basically just a lambda. In this case, all we're going to do is just print something if it's empty. So we'll just say the spot is empty. And now, as I was saying, we're going to have to also tell it what to do in the event that the field position is occupied. So field position, occupied, and we'll just print something like this spot is occupied. And also need to come back up here because I forgot to actually tell it what I'm matching on. So the spot is occupied. So now if we run this, should be matching on empty. So we should see there this spot is empty. Awesome. And you see there again, if I delete that, it goes back to red. We have to have that second position there, or it's not going to be happy. Pattern occupied, not covered. And you'll see there that pattern occupied, not covered. That's a good example of the Rust compiler. While it is very opinionated and you have to get things right, it's also very helpful. It tends to do a decent job at kind of telling you exactly what's wrong. So it usually gives you some pretty good hints at how to fix things. And I think as you're learning this, you'll just be kind of having a dialogue back and forth with the compiler a lot. Sometimes an angrier dialogue than others, but the more you get the feel for it, the less you'll be grading against it. I think it's really just kind of coaxing you into some patterns that you should be having anyways when you write code. But wait, there is more to enums. As I mentioned earlier, in addition to the match, I'm going to show you something else cool here that you can do in conjunction with match. So first, we're just going to create another struct here just to give us a little bit more to play with, kind of building out our example. So maybe in addition to agents on this field of play, we might have some objects. So we'll create an object type as well there that can be solid or not. And now what we're going to do here is we're going to change this enum and we're going to have occupied by agent. Notice there I've passed it in the agent type there. Or we could have occupied by, you guessed it, object. So we'll pass in the object type there. And now what we're going to see here is we're going to go ahead and define some instances of each of these. So we'll have our field position occupied by object, and see there I need to actually supply it with an object instance. So what I can do here is for any, say, spot in my field of play that was occupied by an object, in addition to saying it's occupied by an object, I can supply a reference to that object. And I could also have multiple things in there as well if I wanted. So basically that's going to give us a way to, when we match on that, to do something with it, to have a reference to instance. So we have an object here, it's a happy little tree. And it's happier if I give it a string rather than a string literal there. And now we'll just go ahead and define another field position here. And we'll go ahead and place our agent in that position. So this one is occupied by agent, and we've got a field agent there. So now we're going to have to update our match signature here, make it happy again. So we're going to have to match on by agent as well as by object. But now we have a reference here to our agent, which we can operate on inside of our Lambda here. So we'll just print the spot is occupied by agent name, in this case, Maxwell Smart. So field position occupied by object. This case, he's hiding behind this happy little tree here. So this spot is occupied by a blank. And object should also have a name. So we'll just print out object.name. And we need a comma there. And go ahead too and just print out the solid just to show you that, you know, this is that object and that we have access kind of show this is a different type. We're dealing with two different types there. So if we go ahead and run this match on field position 1, nothing really changes from before. The spot is still empty. But if we were iterating over an array or something and we were matching on field position 2, now the spot is occupied by a happy tree, and it's solid, as most trees are. Alrighty, so field position 3, this spot is occupied by Maxwell Smart. Okay, so moving right along here, I'm going to show you a little more with enums, and we're going to see how that basic pattern gets used within a lot of the APIs you'll be consuming in Rust. So you'll see these leveraged quite a few places. One common place you'll see them referenced is for error handling. You'll also see them used in place of nulls. So Rust doesn't really have nulls. What you'll have instead is you'll have an enum type you can return that will have the option to have none or some. Some will take the result, whatever it is, of your function, and none will just simply be none, similar to our empty in the last example. In this case, though, what we're going to return here is a result that can either be okay, in which case it takes back our result, or it can be an error, in which case it takes back a string slice there that tells you what the error was. So we're going to do a quick example here. We're going to just have a run command function that takes a string slice there, and it's going to match on that, and it's going to see if you want to make a sandwich. Unfortunately, making me a sandwich is not enough. That's kind of rude. You're going to need to try using sudo if you want this command to make you a sandwich. Wouldn't want any security vulnerabilities in our kitchen. So now we'll have an else if here. Notice I tried to put a parenthesis in there. You don't need parentheses around if commands in Rust. I suppose they consider those redundant. I'm still trying to get used to that. So now, if we sudo make me a sandwich, we're going to return OK. So OK there, inside of it we can stick whatever kind of result we want here. And in this case, we're telling it that we want it result to take a string. So we're going to send it back, dinner is served. And again, string from is necessary there. I believe I might have also been able to call .into on that. That's another way to accomplish that. There's a lot of ways to cast things in shortcuts. So if we don't match on anything, we're just going to go ahead and return the error variant of the enum and pass it a string. In that case, it really does want a string slice. So now let's run our command. And let's see if we can make it do the dishes. I mean, if it's smart enough to make a sandwich, surely it can clean up when it's done. So run. Well, nothing happened. Why is that? Well, it looks like we didn't actually print anything. What we're doing here is returning an enum. So we need to actually do something with that. There's a lot of different approaches we could take here, but for simple example, we're just going to stick with the match pattern we'd already shown. So we're just going to exhaustively match on the results of this function. There are some shortcuts for unwrapping these standard enums, but let's go ahead and match. So we'll handle the OK case, and if it's okay, we'll just go ahead and print out the string that it returns. Command said, hopefully dinner is served. And now we have to handle the error case. And again, we'll just go ahead and print out whatever the error case happens to be, whatever message that we decided to pass back. And like I said, you'll see this pattern all over the APIs of returning these OK and error. And in this case here, Command not found. It does not know how to do the dishes. So let's see if it can at least make us a sandwich. And of course, I think you see where this is going. Nope, we've got to sudo make a sandwich. And yep, dinner is served. So that's enums, and really I feel like I'm still personally wrapping my head around this pattern and all the things it enables. I think it really sort of broke my brain when I saw that, and I'm still trying to think of the different approaches I can take to structuring my code that really leverage that. Though I did discover one unfortunate thing later on when we get into combining this with wasm. You cannot use wasm-bindgen, which we'll cover a little later, to export these sorts of enums into your JavaScript layer. But as long as you keep them tucked away inside of the Rust WebAssembly layer, you should be fine. So, brief look at ownership. So, ownership is one of the coolest and most annoying parts of Rust. It is the reason that you do not have to either depend on a garbage collector or implement your own pattern for acquiring and freeing memory on the heap. So basically, what we'll see here really quick is that ownership is all about dealing with that heap and when to free resources. Show you really quick, you don't have to worry about that with some very primitive types that are just going to live on the stack, but anything else, ownership is going to come into play here. So there are 3 golden rules of ownership. Each value in Rust has a variable called the owner, and like the Highlander, there can be only one. At least there can be only one at a time. You'll see where you can in fact move them around, but at any given point in time, there is only one owner. When that owner goes out of scope, the value is dropped. So at compile time, it's going to be looking at this, and if your code's valid, it's going to be inlining some kind of drop statement there. Each time your owner goes out of scope, that guy is gone. It's deallocated. There's a lot of ways in which you can make mistakes in which it can't properly determine this, in which case the compiler is going to yell at you. So this ensures that there's a whole class of bugs related to memory management that are really common in C++ applications that really just can't happen in Rust. So first, really quick example here. Let's just deal with a very basic variable assignment operation. We're just going to assign integer 32 to x, and we're going to assign that back to over to y. And we're just going to kind of show that this works here. We can print out both these values, and they should both be the same. And we'll see this is going to work pretty much like it does in any language because, as I just mentioned, these values live on the stack, and the whole ownership thing that we're going to look at next doesn't really come into play here. So now what we're going to do is look at another example, but this time we're going to bring up our old friend the string again. So we're going to do our string from, and so now what we have is a string that's allocated to the heap. So this str value here, it is going to be subject to those 3 rules of ownership we mentioned earlier. So currently that some value for the heap, it is owned by str. But now we're going to, as before, assign it to str2. So now the ownership has moved. So str no longer owns it, but str2 does in fact own it. So now we'll see how that impacts our print statement down here. So we'll go ahead and we'll print, as before, both values. So we'll try to print str, and we'll try to print str2. And let's just go ahead and pass those in. And let's try to run it. And angry compiler. Basically borrow of moved value str here. It does not like it. We're trying to use this value after it's been moved. So it will not let us use str anymore now that it's been reassigned to str2. That name is dead to us. So if we take that out, yeah, we can print it as long as we're only using str2. Now that could get really cumbersome if that was always the case. So what we'll look at here next is what we call borrowing. So it can only have one owner at a time, but there is a way to just borrow something. So what we'll do here is we'll go ahead and put that back in. So we're trying to log out both again. If we were to compile it now, it would be broken again. But this time instead, let's just add a little ampersand here. That tells us the str2 doesn't actually need ownership of str. It just wants to borrow it for a minute. So now we can actually have access to both of those values. So real quick, we'll just do some more playing around here and see some other stuff you can do. So right now we've got a string there that's mutable, so we're able to push new values onto it. By default, everything here is not mutable, so you have to apply that mutable. And then now we've done similar to before when we borrowed the string, except this time what we did was we did a deep clone of it. So we've just created a second mutable string here that is a clone of the first string. So now we basically have two complete strings that we can work with. So they're now going to have two different values. You can operate on those independently. So that's another thing you might want to do if you're hitting up against that borrow checker. There's a good chance that maybe what you might want to be doing is cloning it. You might want to be borrowing it. You can also do what's called a mutable clone. We'll just play around here for a second and show some of the different problematic states you can get into. Really, if I just kind of type and play around, I guarantee you I'm going to break this pretty quick because it's pretty easy to do. So right now we're kind of back to before where we're borrowing that. If we try to now push to it when all we've done is borrow it though, we're going to be back to this error again because what we've actually done is just borrowed an immutable reference to it. What we can do here is specify mut, and there's now a mutable reference. But we're now back to our original edge case where if we borrow something immutably, we've now can no longer use that first variable. So for this scenario, we have to go back to now only just referring to it as str2, and it's now happy again. Another interesting thing to point out, I'm not going to go ahead and type through it, but you can shadow variables in Rust. So we could potentially simply say let mut str equals and mut str, and then we have kind of a new mutable reference that's also called str, though not technically the same as the first str. So you can also do some interesting stuff with that. It seems to be a common and encouraged pattern in Rust is to shadow variable names. Personally, I have an aversion to that, having come from the bad old days of JavaScript development, where that was really common. And I feel like that's one of the reasons why we added constant let to JavaScript and why it's discouraged to use var. One of several reasons. That is just nasty and I think leads to bugs. It could be a little better in this case because in the JavaScript world with var you also have hoisting, so that variable can be kind of declared anywhere in scope. So I think that makes it a little nastier, at least here when you're shadowing. There's a clear linear progression that's happening in the scope, but just something to keep in mind. It's something you can do. It's something you'll see. Whether or not you want to do it, up to you. So one more quick example here with ownership. We'll take a quick look at how that all plays out in a scenario with a function here, because that's where you'll often see it come into play. Usually you're going to have multiple functions. You're not usually going to be doing what we were doing there and reassigning a variable to a different name within the same function. But you will often be trying to pass variables to other functions to do something with them. So in this case, we're just sort of doing a dumb, does this string contain this other string? So we're going to pass in two strings. Let's get down to brass tacks. How much for the ape? So pass in another string here. I apologize for the Fear and Loathing reference. Couldn't help myself. So we'll find out if in fact there is an ape for sale here inside this string. So you also notice I'm using snake case here. That style guide compiler in one that I mentioned earlier will politely tell you should be using snake case a lot. That is kind of the standard in Rust. I'm still getting used to that as well. I'm not a huge fan of snake case, but I try to, again, follow the standards of what everybody else is doing in an ecosystem. It helps everything play nicely together. So we'll go ahead and print out that result there. And nothing too shocking here. Is it there? Yes, it is. But here's where the rules of ownership are going to come into play. We have passed has_val to that contains value function there. That contains value there, that became the new owner. And then it went out of scope, the function ended. So what happened to our value? Well, as you'll see here, what should happen to it is it should get deallocated. So the compiler knows this, and it knows that we shouldn't be asking for it anymore, and it's going to say, whoa, 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 yeah, I can't give you that. So what do we do here about this? Because obviously this is a common scenario. Well, one quick fix in this case, we're not going to be doing anything to that string. All we need to do is say that we're just borrowing that string, and then we need to make sure that we're passing it as a borrow. And now basically the compiler knows that contains value isn't really, that those str and value instances inside of contains value don't really own that value. They're just borrowing it. So when that function ends, those will not be cleaned up, and so we'll still have access to it. So now let's start to tie things together here. Let's bring it all together into a big wasm Rust bear hug. And in order to do that, we're going to be relying on this awesome tool called wasm-bindgen, which I know it's spelled differently, but always really makes me want a glass of gin. So what is wasm-bindgen? Well, it's sort of a couple things. From their documents, it is a Rust library and CLI tool that facilitates high-level interactions between WASM modules and JavaScript. So going back to that example we did earlier with the naked WASM, it can get pretty complicated, especially once you get beyond just simply passing back integers. So what wasm-bindgen is going to do for us is to allow us to pull in a library that pulls in some macros and annotations that can do a lot of the glue of converting between things in the JavaScript world and things in the Rust/WebAssembly world for us. In fact, we'll use it in conjunction with something called wasm webpack build here, and it's basically sort of a full stack toolchain here for this. What it'll do is it will build out not only compile the Rust into WebAssembly, but also build out TypeScript definitions, wrappers around all of our functions, and glue on the JavaScript side, so that basically what we'll end up with is nice little ES6 modules that we can just import into JavaScript and interact with as though they were JavaScript, even though what we're actually doing is executing WebAssembly code. So it is pretty awesome. So really, I'd say it's just plain magic. And honestly, I only have the barest beginning of understanding of all the magic it's doing. There are some great documents out there that will explain this and try to go through some of what it's doing. And a lot of this, it's all open source, so you can take a look at it. And I recommend you do, because it's pretty cool stuff. So we'll take a look at a basic structure here of a one of these projects, and there's actually a generator for this. So this is all basically generated code at this point. So this is what happens if you run the kind of wasm gen generator. It's a mouthful, but you can look up some good tutorials on how to do that and how to install that tool chain. And then basically what we got here is we have a node server. and it's going to host this application for us and rebuild it. And right now all it's doing is it's saying, hello wasm-pack. So that's the basic hello world that it generates for you. And it's pretty cool there. What it's actually doing there is pulling the hooks into the browser's alert functionality into the wasm side of things, so that in Rust we're actually allowed to call alert and flash that up. So we're not actually returning a string to JavaScript and having JavaScript do that. We're doing that from inside Rust. And you'll see that that's a cool option you can use here, is that you can pull the DOM into the Rust side of things. But first we'll just do some really basic examples. So we'll just decorate this here. I'm not sure if this is properly called decoration or annotation, or what the right term for this sort of macro here in Rust is, but we're gonna decorate this function here with wasm-bindgen, and we're gonna have it get a number. It's gonna return us 42. So this is basically the example we did earlier in naked WebAssembly. Now we're gonna just go ahead and do another function while we're in here, and we're gonna have it return a string just to show how easy that is as well. So thanks to the wasm-bindgen, this is all pretty easy. It's not going to be happy with that though. I've got to tell it what type that is. So here we go. Make sure this knows that we want to return a string. And that into is making sure that that slice is getting cast to our string for us. So if we go ahead over here and we build that with the wasm-pack build, that's going to update our binary dependency. And then we're going to have to go head over here though to our node project and update our index here real quick. So before we were calling wasm-greet, we're going to want to call our functions. And actually we're not really quite doing this import right. So what we need to do is we need to import our functions. So we're going to get a number, and we're going to see there the autocomplete's showing up for us, which is nice. I really love the IntelliJ projects. They're really great at this sort of thing. We're also going to want to get a string, but we really want to, for these purposes, get it from the package there. And what that's going to do is allow us to every time that gets built, that package will get updated, and we'll have all our new stuff there. And so now we can call get a number here, and we can just assign it to a JavaScript variable. So we're now getting back that 42, and we're assigning it to num there. And we can just as easily do the same thing with our string value. And now we can do whatever sort of JavaScripty things we want to do with them. Console log them, add them, append them, general ES6 fun. So num is num, and str is, you guessed it, and you'll see there it rebuilt for us. So if we refresh the browser, we won't get our alert anymore. Instead, we'll get some output in the console. So you can see down there in the console, num is 42, str is hello from Rust. So that is now working. So next thing we'll do here is we'll take this just a little farther, and we'll show that you can also make some structs, and you can have functions that return those structs, and you can call those and access those from JavaScript as well. So I have a simple foo struct here that just has a value on it, and we'll make a getter that gives us a new foo. And honestly, we could have, and this is a pattern you see a lot, we could have implemented this getter to return a new foo on foo itself as a static method, and then we could just have like foo : get a foo. You'll see that a lot. You don't really see constructors in Rust. What you instead see is these kind of builders. In this case, it is unhappy with me. Why? Can't leak private type. Ah, yep, we need to make that public. And you'll see you have to kind of be careful with what you make public and private, and what you do and don't try to expose through the wasm JavaScript boundary there, because some things the bindgen can handle very gracefully for us, and some things not so much. And so I think a key of this is going to be designing your APIs carefully around that interaction between the JavaScript and the wasm boundary here. So console log that out, and yeah, foo has a value of 12. So we got back our foo. We could access the dot value on it from JavaScript. In that case, everything was hunky-dory. So now we'll show a scenario where it gets just a little bit trickier. So far, these types we've been exposing on the struct have been pretty simple, but getting tricky here. We're going to expose, say we want to expose a vector, which is going to be, again, it's going to be allocated on the heap. It's dynamically sized. If we just tried to expose that directly, we would have problems. So we're going to skip over that. I'm going to cheat here. I'm going to give this thing a size. There's probably some different, better ways to do this, but for the purposes of demonstrating this, this will show you a way you might be able to expose a vector called numbers here. Get all our commas in the right places. So foo now has a size, and it now has a vector called numbers. And for the purposes of this example, size will be the size of the vector. And so what we're going to do here is we're going to notice we left off pub on numbers. We're not going to try to publish that across the wasm-bindgen barrier. It's gonna be angry if we try and do that. It won't compile. So instead, what we're going to do here is we keep that private, but we're going to have a public instance method called numbers, and it's going to return us a pointer to an unsigned 8-bit integer there. And so we're going to just return that as a pointer. Basically what that's going to do is that's going to return us a pointer to the start of our vector there. And it helps if we update our generator function here. Get a foo is going to need to go ahead and give us a instance of our vector and a size. So we'll just go ahead and make that size 3. And we'll stick some numbers in here. I just gotta think of some good numbers and try to remember this macro here. So vec. This vec bang is useful. That just lets us kind of inline declare our numbers. So we got 10, 9, 8. Aborted countdown, I guess. So now what we'll do here is on the JavaScript side, we can get at that pointer. And if we get at that pointer, we can reconstruct our vector over here on the other side as an array. So first we'll just get the pointer off of foo. So numbers, that's going to return our pointer. And then now what we have to do here is wasm-bindgen provides us with this dependency called memory. We'll construct a U8 array, and then we're going to pull in memory. And we're going to access memory.buffer. Now we're going to just pass it that pointer. Now we're going to pass it the size. And that's going to construct for us an unsigned integer of 8 bits. And we'll be able to now see that that is basically reconstituted intact over here in JavaScript land. So we can now step through that array just fine. So you see there where it can get tricky. You can pass back and forth really primitive types, but it starts to get complicated fast once you start trying to do things that are on the heap. So personally, I'm still learning a bit about how I want to deal with this in my projects, but one of the ways I've been able to deal with it is that a lot of what I want to do doesn't necessarily have to live in JavaScript. So just instead of passing stuff back and forth a lot, I'm relying on the fact that wasm-bindgen provides a very good interface for manipulating the DOM and doing all the sort of standard ES5 plus kind of queries you might want to make. You can query for elements, you can add stuff to them, you can manipulate a canvas. So mostly what I'm doing is drawing to a canvas. So I'm just keeping that inside WebAssembly, and then I don't have to cross that boundary very often. That could be a little restrictive though, because one of the great things about this is this option for interplay for getting the best of both worlds. So as I was mentioning earlier, I think another thing is to just think carefully about how you encapsulate your Rust logic and to be able to expose things in a way that is going to play nice, but you could still do more complicated stuff under the hood. And then, of course, at the end of the day, there's nothing keeping you from getting down and dirty with some CS and just passing back some pointers and trying to figure out how to deconstruct those things into JavaScript objects yourself. Then finally, also another option is that there is a library called Serday. I'm not sure if I'm pronouncing that correctly, but it will allow you to do serialization and deserialization to and from JSON objects. And so you can also use that to pass things back and forth across that boundary. So finally, moment of truth here. Let's have a moment of silence for the demo gods. And I'm going to do the only part of this talk that is live, and I'm going to try to run some demos. So these are some of the things that I've been working on with Rust. I make a lot of, done some interactive art exhibits, and I like to do art projects in the browser. Often they're displayed on a kiosk or something, but I kind of got into doing these things in around, when ES5 was big and stuff, and I find it to be a really cool environment for rapidly developing things. And you combine that with some stuff like Electron and a lockdown machine, and you can build out some pretty cool kiosk applications with this. There are some places where I've hit some bottlenecks in some of my applications though, so I started playing around with this, thinking that it might be a way to improve performance on some things. So one of the first things I started poking at here is these applications I've been playing around with that are based on DLA, or dynamic limited aggregation algorithms. So this is a really simple algorithm I've implemented multiple times in different places, different languages. So I thought that'd be a fun one to start with. And I had a particular JavaScript implementation of this that was starting to kind of get unhappy when I was trying to generate things that were 1080p with it. So I thought I would see if this would speed it up at all. So first thing I did was I built a version of it that was just in raw Rust that you can run on the command line. And if I was to cargo run this, it would just execute here on the command line, and it would spit out one of these PNG files. I'm just going to skip to the end result rather than spare you sitting there and waiting for it to run. The way I've got it set up now, it probably takes it a minute or two. So we'll just go over here to projects, and we'll go ahead and open one of these and just give you an idea of the kind of things this generates. So let's go in here and let's pull up one of these. So this is the sort of thing that this guy generates. So what it does here is there is a random walk, and you'll see this more clearly in a second when I show you the fully tied together WebAssembly version. But we see this field with some random particles, and they, for each frame, do a random walk. They randomly go left, right, up, down. And if they reach the bottom of the screen, though, they get stuck. And if another one of these particles touches them, they get stuck. And so it's just a really basic, simple pattern out of which these complicated branching structures emerge. And once you have these basics working, you can play with it and you can create some more interesting looking things by, say, varying the color at various depths, or having certain classes of particles have different degrees of stickiness, or having some stick more to one side than the other, or changing where the initial sticky point is. There's a lot of fun stuff you can do with it. So now really quick here, let's actually run this full WebAssembly version here. So it should already be all built and compiled. So in theory, all I have to do is npm start, and we should get a server stood up here on localhost 8080. And we should be able to come over here and run that. Let's grab a Firefox tab here. And we'll see here, as I described, right now what we have initially is just what looks like a bunch of tiny little dots sort of randomly squiggling around. And you'll see they're starting to slowly accumulate at the bottom of the screen here, all getting stuck. And as they get stuck, they start to form the branches as described earlier. So this is sort of just the very beginning initial stages of this. And there's quite a few other projects not related to DLA and other things I've done, but all sort of related to kind of generative art and stuff that I've traditionally implemented in JavaScript, and that I think might be good to convert pieces of to Rust. As I mentioned earlier, in this case, to sort of get around some of that complexity to get this up and off the ground, of going back and forth between that barrier for this application, this is pretty much the JavaScript code. All it does is it has access to a struct that I've created in Rust. It basically gives a generator there, like the number of dots that it wants to start with, and the size that it wants, and the ID for the canvas on the page. And then from there, Rust kind of takes over and starts updating the canvas. And you'll see there's a lot of great documentation out there for this sort of thing online. There's a really great Rust wasm walkthrough that implements Conway's game of life, which is the first thing I started with. So I highly recommend checking that out if you want to learn more about this. I am going to go ahead and wrap this up now, but you will find links to a lot more information down below this video where I post it, and I highly recommend you go check some of those out and have some fun with Rust in the world of WebAssembly.